about Spark, Apache Spark. My name is Orlando Karam, and since it's a weird enough name, I get to keep it on every email server. So either at gmail.com or at microsoft.com or at outlook.com would work. I am right now working at Bing display ads within Microsoft. And we don't use Spark, but just a couple of things. If you have a question, ask right away. We don't have to cover everything that's in the slides or anything like that. And it's a lot better than you falling behind. I don't mind, that is. And just in case anybody cares, we are being recorded. I don't. You probably shouldn't or don't, but just in case anybody cares, fair warning. Okay, so what is Spark? It is a distributed data processing framework. It is yet another Hadoop, right? It is based on a slightly different idea, resilient distributed data sets, and it's used for big data processing. What is big data? Depends on who is selling it to you, right? It really depends. My definition of big data is when it's a pain to deal with your normal hardware, and it depends on your normal hardware, right? Relational databases are amazing. They don't scale above 1 box. After 1 box, then you need to do special stuff, right? Now, 1 box nowadays is a Core i7 or a Xeon with who knows how many cores and 96 gigs of RAM. So it scales pretty widely, right? Scales pretty big. But still, once you get out of there, then you need other kinds of tools, right? And if your box has 4 gigs of RAM, then big data is whatever doesn't fit in RAM, right? Or whatever doesn't fit in your relational database. And Hadoop and those guys came up with this idea. Relational databases are all about query optimization and things like that. Hadoop is about let's do the dumbest possible way, but let's distribute it. And then if you have 100 computers, it'll work fast enough. So Spark is kind of a next version of that. It is based on the idea of resilient distributed data sets, RDDs. What is an RDD? It's just a huge list of objects in memory. It's so big that it doesn't fit in 1 computer, so we distribute it over a bunch of computers. That's basically it. That's all the magic there is. It is really cool because now you can basically scale horizontally reasonably well. So what we do is we divide our big set of objects, our big list of objects, in slices, keep each slice in a different computer, and now we have a lot more RAM, a lot more computing resources. There is a couple of things that make it nicer, right? If you were implementing this, it wouldn't be that terrible to implement, right? Distributed computing servers is still a pain, but it's not that amazing. A couple of the amazing things that Spark does, most of this stuff is not computed. Most of this stuff is lazy. So when you do an operation, you think that it's going to do something. It just tells Spark, whenever you need the value, go compute it. So that makes a lot of the things appear faster. It's still the same thing in the end. You have to compute it eventually. But, and the really, really cool thing it does is fault tolerance. Since it knows how you got to that big list of objects, it can keep in memory how it got to it. So if a node goes down, if something breaks, it's okay. It can recompute the piece based on the previous operations, which is really nice when you're doing something in 100 nodes, one of them is going to fail. Or if you do something in 100 nodes for 100 days, then one of them is going to fail. And we can actually hint to keep the things in cache or even on disk. And since Hadoop is the thing in cluster computing now, it interfaces very well with Hadoop. Hadoop is kind of C for clusters nowadays, for big data kind of clusters, not HPC kinds of clusters. There is one seat there. One thing that is slightly different from other lists, right, from lists in Python or something like that, is these lists are immutable. It's an array, but you cannot change it, ever. All you can do is compute a new array. So this is more like functional programming, more like scheme or LINQ or any of those things. It feels slightly weird, but once you get used to it, it is fairly nice. And the other important thing is it's magical halfway, but in a wider sense, it's just a big list. All you know about lists still apply for the most part. In fact, the first part of the talk, we are going to do it with Python. There is a couple of other things that Spark gives you besides the big list. They give you shared variables. You can have broadcast variables, which you send a copy to each node. If you need some constants in your computation, you can send them to broadcast variables, and they are slightly more efficient than sending it to every node. They will propagate with nicer algorithms. And it also supports accumulators, which every node can only update, can never read, and then eventually the end result will be accumulated on the main node, the one where the output is being produced. So, since Spark is mainly big lists, let's play with lists in Python. But let's play with them in the functional programming way. So we are going to talk about functional programming. They are already in Python. Python used to promote loops. I think now in Python you would do, and somebody was pointing that out to me, you would do list comprehensions. Is that what we call them in Python too? Cool. For loops with lists. They are basically doing the same thing. And if you know SQL, this is also what SQL does, except you see it in slightly different contexts. But mainly what we have are things that will operate on a list and produce another list, right? The Python tends to have normal names, but the ideas of functional programming have been reiterated in many languages, so other languages may have slightly different names for this thing. One of the things is map, and map applies a function to each element on a list and returns another list with all the results. It's kind of the fundamental one. Filter will only select the elements in a list that satisfy a given function. Reduce, and basically map is select in SQL, right? Do you guys know SQL well? Let me see, can you raise your hand? Okay, then I'll be using SQL analogies. Because map is basically when you do a select in SQL and you put all the fields. That's what map does, right? It lets you get different fields or different expressions from a field, right? Filter is your basic where in SQL. Reduce is your group bys, or we'll see actually, it's not so much your group by as your aggregate functions. So if you're doing count or something like that, that is what reduce does. It transforms all the elements in a list into one value by applying a function repeatedly to pairs of elements until you get only one value. We will see, once you start writing things for functions for map, filter, reduce, many times it is more convenient to just write a simple expression rather than defining your full function. So we'll see lambdas in Python. And if you like functional programming in normal Python, itertools has a lot more stuff. We are going to talk about flat map just because it is used in Spark. So, map. You apply an operation to each element of a list, return a new list with the result. So if we have a list, a equals 1, 2, 3, you define a function add 1 of x, terribly complicated. You call map, this will return a new list applying this function to each element. Does it make sense? Actually, let me get out of Spark, normal plain Python. And we can type these kinds of things. Def magical. We can add numbers. Have you guys done this kind of stuff a lot? Yes? No? Maybe? Sometimes? Okay. Now I'm assuming you guys are typing this stuff on your computers, right? Or saying that I have done this 20 times. Good. It's probably more common to use a for loop, but just important thing, right? The list, the original list is never changed. We have a new list. The original one is still there. Filter will allow me to get some elements out of a list, right? Or get only the ones that I care. So if we define a function isOdd, we can apply filter isOdd of A, and that only give me the odd elements. And range in Python gives me a list with a bunch of elements, so I can produce lists easier. Reduce applies a function to pairs of elements on a list. So if we have a function add, which takes two arguments, x and y, returns x plus y, it's going to add 1 plus 2, then 2 plus 3, 1 plus 2, then that gives me 3. Now that 3 plus this new 3, 6, and then that 6 plus the 4, 10. Does that make sense? Reduce takes a list, gets you one value. What happens if our functions are not commutative? What happens if you do minus? What value do you get? It depends on which way you go, right? It depends on which order you go, right? Python has an order. I'm assuming Python uses the same order going from beginning to end. It is usually a bad idea to do those things with non-commutative functions. In fact, in Spark, there is no order because it's all in parallel, so it's happening whatever, whenever. So always use commutative functions, plus and times and things like that, not minus or divide or things like that, or you may get in trouble. Does that make sense? We were defining tiny functions like add one. It is doable. It is many times easier to have an expression that returns a function. That's what lambdas are. So when we do lambda x colon x plus 1, we are saying, define a function, don't even give it a name, I don't care what it is, because I'm going to use it right now, right? And then it returns the function that takes one argument and returns that argument plus 1. Does that idea make sense? It is just so you don't have to do to write tiny functions. Some limitations of lambdas, you can only have one expression. You cannot go to town and write 4 loops or 17 things in there, right? You don't need to write a return because that's all you're doing. You are returning a value, right? And I always put parentheses around all my lambda expressions, even when you don't need them, because I do extra parentheses. Depending on the syntax, you may or may not need to. So rather than doing our map with add1 and having to define an add1, we can do map lambda x, x plus 1 of 1, 2, 3, and that will just do 2, 3, 4. Does this make sense? You've all done this. It's all easy. Cool. Do we need to do this? Let's quickly go. What's the first one? What would that return? 6, right? Second one, 2, 4, 6, right? The third one, 1, 3, 5, right? We are operating on tuples, which are pairs. They behave like lists or arrays or something like that. And we are selecting the first element, which is T of 0, right? So we'll get 1, 3, 5, right? The reduce will get us 6. And what would that give us? right? And you can combine that to your heart's content, or not. If usually once you start doing this, you tend to nest calls to maps and reduces and things like that. If you don't like it, feel free to define intermediate variables. It's more a matter of style. Whatever works for you, works for you. Shall we try to write some of this? Or shall we consider this settled and you know Python? It's still worth it? Still worth doing them? Okay, so let's try to write an expression to get only the second elements of each tuple. You're assuming that you get a list of tuples, right? So how do we get the second elements of each tuple, right? What do we use, map, reduce, or filter? Map, right? Map, and let me do it with lambdas. It's a tuple, so I'll call it T. T of 1 gives me the second element, right? And since I always get confused, I don't trust the parser to understand that that's a lambda. I put parentheses. That's me. You don't need the parentheses. The parser knows. On A. Now, get the sum of those things. So what do we need to do now? Reduce, right? the sum of the odd first elements. So first we need to get the first elements. We can modify this thing, right? Now we want only the odd ones, so we can actually cheat. Or again, use a lambda. And then get this sum of those, right? It's all good. It died. Sometimes we end up with a list of lists, and what we want is one big list. And so if that happens to us, what we need is flat map. Spark calls it flat map. I don't think there is a standard name in functional programming. Haskell uses some weird symbol and calls it something else. Python doesn't actually provide you a flat map function. You have something very similar in itertools.chain. If we try to do we are going to map something to a list of tuples. We can use our A. We can do something like this, right? What this gives us is two lists, right, inside another list. This is what we get. Sorry. And if what we want is one list with all those elements, we can use we can import chain from itertools and then do apply chain to this, and that will actually give us an iterable, and then we can do to list. Ah. Ah. It's not to list, it is. Ah. Use my trusty cheat sheet. Do you understand the concept of flat map? We'll do it in Spark rather than doing it in Python. I have the code somewhere. But so let's try to start Spark and see what happens, right? Chances are you download the Spark and have it somewhere, maybe. Then if you go to whatever that folder is, there should be a bin and then a pyspark inside there, and that should give you Spark. Ah. If anybody is having trouble, let me know. Are you? Sorry? No. Do you want to SSH? I have VMs. Do you want to SSH into a remote machine that has Spark? Okay, let me give you. Trying to find paper. Somewhere I should have. Sure. You should be able to just, thank you, SSH. There. 7. Do you all have Spark running? Yes. Cool. You have it on IPython, which is even cooler. What? No, he has it on IPython. You'll have it. So good. Cool. This is the shell, which is really cool because it lets you just type stuff and it works, right? If you'll probably use Python, so you don't know the pain of having to use a compiled language and having to compile stuff. This is beautiful. You can type and learn over here. It does a couple bits of magic. It defines a Spark context object, and it calls it SC. So if you type SC, you will see that you have stuff. we are going to talk about this way later, but you have also another thing called SQL CTX, which is a SQL context or a Spark data table context, which is a cool new thing that just came out in 1.3. You all got the context? Life is good. So, all Spark commands operate on RDDs, a big distributed list. The easiest way to start with that stuff is use sc.parallelize. sc.parallelize takes your list of elements and sends it to Spark and returns an RDD. Bless you. Of course, later we'll see how to read from files. When you parallelize something, you get an RDD. And you actually can see a little bit. You're not supposed to, but it kind of happens, right? You get different kinds of RDDs depending on which operation you did. In this case, we get a parallel collection.rdd. Now, let's call first and go fix one problem, maybe. This sc.parallelize doesn't do much. It just says, oh, if you ever need to compute this, right, send it to Spark. It doesn't actually send it. When you call first, then it actually does stuff. And many of you get a wall of text with stuff logging. Is that correct? We can go fix that. Spark is actually not a Java application, it's a JVM application. It's actually written in Scala. But it uses the same kind of stuff. It uses log4j, which has a configuration file. And for Spark, it is at in the conf folder. The easiest way to fix the wall of text is to get from the repository I added a file in scripts, log4j.properties. You just basically tell Spark. By default, it will log everything because you don't actually have a properties file. I think there is a .properties.template file in that folder if you want to copy that and just modify it. Or if you just want to download this file and put it there, and you will stop seeing stuff. You may want to wait 5 minutes and then do it. If you want to see, initially it is kind of nice to see the logs, but after the second time it's like, I just want to see my result. In the conf folder, conf. Then hopefully when you try something like this, You don't see a while of text, you just see a number. Did you all have PySpark configured so that it doesn't annoy you? Cool. And as you saw, right, the parallelize is actually lazy. It doesn't do a thing. And then it's only when you call first when it needs to actually send everything to Spark and then go get the first element, right? When we get to do it as programs, you'll create your Spark context object. In the shell, you get it as SC, so you don't have to do things, which is nice. So we can start playing with Spark. By the way, there are ways to tell to PySpark to which Spark server to connect. One of the coolest things about Spark is that it has a local mode, so you don't need to set up a cluster. Eventually, if you're dealing with big data, you want it because it doesn't fit on your computer, so you want to set up a cluster, but you don't have to. And actually, if you're lucky enough, you have a sysadmin who sets up a cluster for you, right? And they just give you the address. So that makes it a lot nicer. We'll see how to do that. By default, you are connecting to local. It actually starts a local instance of Spark, and I think it defaults to however many cores you have times 2 for the number of threads or something like that. So we can do things like sc.parallelize range of 1 to 1000, and then call map and pass it a lambda. I'm going x times 10. It is fast. It is super fast. Why? No, because it doesn't do a thing. It just says, oh, if I ever need to calculate the value, I'll do a map. It doesn't actually do a thing, right? You're going to see that even though you're doing it memory, it's not incredibly fast. One of the slight problems with Python and Spark is that you pay a performance penalty because you're running Python stuff. Your Python objects have to be serialized, sent to a Java program, to a JVM program, operated over there, and then sent back to you and serialized back from Java to Python, which imposes a constant penalty, right? But it is a penalty, especially when you're operating on a list of 1,000 numbers, where you could do a for loop and you wouldn't even notice, right? Then here you can feel the pain. When you have a big cluster, then it's just a constant penalty. It's not that big of a deal, especially since your problem is going to be reading. But when we call something like .first on it, then it goes and does things. Oh, and I put it on list 2. Do this, and then when you do list 2.first, that's one. Slight syntax difference from Python. In Python, map is a function that operates, right? That takes the list as the second argument. In here, map is a method of the RDD object. So you call it with rdd.map. And then you pass the function. That's kind of the only thing. For now, we'll be using lambdas. The advantage of lambdas when you're doing this stuff is that you don't have to send anything to any other node, right? When you have a distributed system, you need to figure out how to send your program. And so Spark gives you ways of attaching files, attaching all your Python modules with your programs. But right now, we don't have any of those, so we are just going to use lambdas for a little while. Does that make sense? So we can call map, we can call reduce. And I cannot cut and paste from here. Now, reduce goes from an RDD onto a list, onto a number, right, or one value. So that one is immediate. That one is not lazy. And then we can call filter to get certain things. So we can do list2 dot filter lambda x % 100 is 0. And then we can call collect to get all the values. Yes. Collect is also a list method, an RDD method. And we'll see a few more in a sec, but I tend to use either first or collect. There's actually take also, and you can do take and pass it a number, and it gets you the first n element. So when you are just trying to see, if we try to do the thing, collect would get you 1,000 elements, take gets you 5 or 10, or whatever, however many you want. And all three of these, first, collect, and take, will actually get the computation to execute and give you the values, and they entail sending stuff from the JVM to Python and back. This idea in the Spark documentation, they divide, right? Transformations and actions. Transformations transform one RDD onto another. They don't actually do a thing yet, right? Actions return a value other than an RDD and are performed immediately. The transformations are lazy. They just say, if I ever need to do this, I'll do it. If you like maths and query optimization and things like that, you are creating a graph of, I need to do this, right? And that is also how Spark can recompute things, because you explicitly told it how to compute it, right? So if it needs to do it again, right, it knows exactly how to compute it. It knows which map or which reduce produced it, and if it comes from other RDDs, what produced those until it gets to truth. Some transformations, we have map, which returns a new RDD. We have filter and flat map. And we are going to see reduced by key which becomes important when you think about group by, basically, and joins in SQL. So we have reduce by key and join, actually. Some of the actions are reduce, take, collect, and sum and all of its friends. Max, mean, and mean, the other mean. So you can do things like that. You can also use max, min. Super quick exercise. Get an RTD with numbers 1 to 10. What do we do? Yay! Thanks. Get all the elements in that RTD which are divisible by 3. That would be filtered, right? So sc.parallelize. Filter lambda x divided by 3, 0. And that gives us those elements. And then we need to do something like collect or something like that. Yay, it works. And get the product of all those elements. So what do we need to do? Reduce, right? So and we start getting to mildly useful stuff. It is incredibly cool that we can do range and play with numbers, but after about 10 minutes, right? It's like, we can read with sc.text file. And that is actually magic because it is Hadoop. It uses Hadoop thingy, so it gets you access to all the things that Hadoop can do. One thing that I really like is it actually, if you pass it a URL star, if you put stars and things like that, it will read all those files. And what this will give you is an RDD of lines. Does that make sense? Now, if I was running this from the right place, I would have stuff in dot dot. Maybe. Where am I? No, of course I'm not there. Let me run it from here. Ah. So you need to adjust the path to whatever you want. If you got the Git repo, I have data folder and I have people.txt. It's a really big data thing. It has about 5 lines. So we get the first element, it crashes. Because I used the wrong path. Why did it crash until I do? Why didn't it crash before? Because it doesn't do a thing until you actually need to execute it, right? It's so lazy. This is really cool, but it just gives us lines. Then we need to do things with them, right? In this case, I'm using tab delimited files, right? So what do we need to do? Split, right? Python doesn't have a standard for what it does, and no programming language has a standard for what they do with new lines. sc.text file eliminates new lines, which is good. 99% of the time, that's what I want to do when I read text files. But every language, just for kicks, right? About half the methods will eliminate new lines, the other half will not. And you just have to try them. So if we do people.split /t, we cannot just split, we have to map, right? Sorry. We must split, and now we get tuples, array-ish thingies. What we got was this. Does it make sense? now we got mild magic, right? Many times when we are calculating data, when we are playing with data and calculating stuff, we want to group elements by some attribute and then calculate a value based on that, right? Is your group by in SQL? In Spark, you can do that with, you have a tuple of key and a value. And Spark doesn't need to know, in fact, doesn't know anything about attribute names or anything like that, just sees a tuple, the first element is the key, the second element is the value, and that's it. And then it allows you to do a reduce on the second elements, on the values, for all the values with the same key. Does that make sense? Some sense. So we load our file. And this is supposedly a database of name, gender, age, and favorite programming language. No imagination, I know. So imagine that we need to find how many people are male and how many people are female. And for gender, we are using M and F. We need to get something that will have keys and values, right? So our key is going to be the gender, either M or F, and our value is going to be 1, so that we can do a reduce by adding. If we add all the ones, that's counting, right? So what do we need to do? We're going to reduce a new tuple. We're going to produce a new tuple with the gender, which is T of 1. And 1. And cool thing is, right, you can just do first or collect or take and see what you have. And now we can do reduce by key. And use our adding function. And again, we get an RDD. Does this make sense? No? A little bit? No. Sorry? Oh, I actually, yeah, I have three rows with male and 3 rows with female. Sorry. Tried to be gender neutral and actually ended up being confusing. Oh, you only have 3 records?
Maybe I'm wrong.
No. 1, 2, 3.
I will take maybe.
Oh,
Maybe I made a mistake.
let's see. Can you just do people.collect? And that will tell you. Are you all seeing the same values? Okay. I didn't just. What do you mean? That needs to be a tuple. There's a parenthesis there. So how do we get the number of people by favorite programming language? It's almost the same, right? Except that our programming language is field number 3, right? So if we just do this. Ah. You have a tuples. The first element is the key. The second element is the value. That's it. No, there are no longer tuples. You use a map to map it to one key, one value. Now the value can be whatever you want. So the value can be a tuple with 17 fields and nested things. The first field is always the key. Yes. And there is one more field. That's it. So you have to do a map first, always to put it in that. Or usually, you have to do a map to put it in that way. It has to be 2 columns. Yes. This is a lot more primitive than SQL, on purpose, right? In a way, you're doing relational algebra rather than SQL. Do you remember they tortured you in class at some point in time with relational algebra? This is what we are doing, almost. And we can do other kinds of reducing things, right? For example, if we use lambda of xy, min of xy, that will give me the smallest value, right? So I can get the youngest person or something like that. This was the example for the youngest person per gender. So it is similar with a couple of things, couple of differences. T of 2 is age, and T of 1 is gender, right? The split gave us strings, so we still need to make this an int. So if we do this, so that gives us, right? And we are doing these are the values that we are going to do reduced by Keon, right? We always have the tuple. As somebody in the back had said, right? At any point in time, you can just do first or collect or take and see your intermediate results, right? That's normally how you produce them. You go step by step, look at it, make sure that you got what you wanted, and keep going. And which is also why you start working on a file with 5 lines, so it's incredibly fast. And then you go try it on your massive data set. But when none of these things are persistent, when you quit, all the RDDs die. In fact, one of the bad things in my mind, but it is on purpose, is you cannot have persistent RDDs. You can persist to files, and then you can read from the files again, but it's not a database. On purpose, it's not a database.
Yeah, so I kind of don't understand the point of you need like an application that has big data in it, like with these kinds of calculations, because reading in those files takes a really long time. So a slow to start up calculator is not very useful.
Normally, at least for now, and we are getting other kinds of stuff, you still do batch processing for big data. So you basically, every day you do that thing, or every so often, you read all your files in, you do whatever you were going to do, and dump it. In fact, I think a lot of people, I know that's what I'm doing, are reading this stuff from text files, right? Aggregating and then dumping it into a relational database, because the aggregates are not big anymore. I mean, they're big, but they're not.
Okay, but I have a related question. So if I do these calculations in memory, can somebody else connect to the...
No, but you can save them. You can save them to a file. This is basically batch. There are things that give you databasey things on Hadoop. There is actually Spark SQL, but it still assumes that you need to read the files. It is what you would do is you would have your application, right? Read the files in, and your application is still in memory. And so you can execute several calls to that same thing. But I don't think Spark gives you anything that gives you the chance to save to a file and that's it. It doesn't, Spark doesn't persist your things in memory, as far as I know. There is also Spark streaming that is for doing it even online-ish. But I think still most of the big data stuff is done in batch. Even if you're doing machine learning or something like that, you just run your machine learning model every hour or something like that, or every day, or depends on how long it takes. We have some processes that take several hours on an obscenely large cluster. one of the advantages of working at Microsoft. We have an obscenely large cluster. It doesn't use these things. It uses our proprietary thing, which is fairly nice, but it's proprietary. So, yes.
So we're writing this in Python, and we know that the Python interpreter is very slow. Having written it like this, is there a way to compile it to something faster?
Actually, yes and no. What you can do is learn Scala, and actually, you don't need to learn Scala because you're only doing these pieces, right? It has the exact same methods. The RDD interface is in Scala. In fact, it doesn't look like Python because it is Scala. The method names and things like that are more. So it is fairly easy to learn. We are going to see there is, and now, that's why I wanted to use 1.3. The data table interface doesn't really do Python, which lets you, if you think about it, the problem here is this, right? Because this call, sc.text file, is not Python, right? I mean, it's just calling. So the problems are in our maps and the problems are basically in our maps and reduces, right? Where the stuff needs to go. There is a Python interpreter running on each node, but the stuff needs to travel between Scala and Python. It is not terribly hard to learn Scala. In fact, I would need to check whether something changes or this exact same code would compile in Scala.
No simple export tool that would take working pyspark and
No. But we'll see with data tables. With data tables, you can, basically there is no Python involved. So it has basically the exact same performance as Scala, which is fairly nice. I think it is about time for coffee. Shall we break and... Okay, cool. Are we back? Cool. You can, of course, send other programs to the PySpark shell. If you define your own Python modules and things like that, you can use --py files to send just plain Python files. You can also send zip files or egg files. And what this will do is send it to all the nodes so you have it available. You can also use --jars to include Java jars, and even --packages to just tell it download the packages from these Maven repos, and so that way it will not download them again if it already has them and things like that. And --files to just include arbitrary files in the home folder. So we can get out of PySpark, and let me see if I can make this not maximized and take off a little bit of my space. Grr. It is Please not my smile. Okay. Whoever asked me, okay, cool. We can get out of here, and if you go to the code simple folder where you have, you should see a person.py. Now we have our module person, and in that file, I just have a class person, has the name, the fields name, gender, age, and favorite language. It basically does the parsing. My own convention, there's no convention here. I just have a method called parse that will parse a line into that person. But now we have it here, so now we can do people equals sc.text file, and if you are in that folder, there is 2 dot dots. No. Oh, it's people.txt, right? English always trips me. Yes. And now we can map person. Makes sense. We can do things like this, right? Yes, sorry. You just do --py files. Yes. I have no clue. You can go read the source code. It's like, that's the point, that you shouldn't care. Until you have to, yes. Actually, it may even depend on the underlying things. Because actually, it can either use its own scheduler or Hadoop. So I don't know if when you use Hadoop, it does something different than with its own scheduler. I haven't looked at the source code, but it's officially not that bad. It's not that big. It's not something insanely big, but. Bless you. So you can get objects. It's slightly nicer. It is still not incredibly nice because your reduce by keys and things like that are done with tuples. You still have a tuple, and your first element is the key, and the second is the value, and that's all you have. But it allows you to do Python. So now our maps and reduces and things, and maps mainly can have these kinds of things and use t.gender, right? Because now we have a Python object. Does that make sense? I'm gonna. I'm pressing the wrong things. I'm going to quickly switch to a slightly more involved example, and then we're going to use it forever. I'm going to try to go super fast on this piece because it's very similar to what we have done, and then spend some time on the data table because the data table doesn't pay a performance penalty when you're doing Python. This stuff pays a heavy performance penalty. You have your Python object that has to be serialized and deserialized for every map and every reduce and things like that. So that makes it, it's still parallelizable, but it is a lot slower than Scala. So we have a sales file, which is, and actually my slides are wrong, it's in data/sales. One of the cool thing is this. We can put a star, and Hadoop will do the file replacement. It can even replace within folders and things like that. So you can read an obscene number of files in one go. So let me just make sure that I can load that thing. We can do the standard splits and things like that. Reduce by key, again, right? Has an RDD of key value, we'll apply reduce. So we could do things like sales by store, sales by day, sales by product, all those kinds of things. We're not gonna. Haha. The other thing that Spark gives us is joins. And this completes all your relational database stuff, right? We can do select, we can do where, we can do group by, and we can do joins. And that gives you basically all you need to do for data. The joins are very simple. Again, you get keys and values, and it does a join. And that's all you have. It only does joins on equality. And you have also outer joins if you want, and Cartesian if you really want to do horrible things. That does the Cartesian product, which is usually obscenely slow. It's every element in one RDD with every element on the other RDD. So. A super simple example. We have a list of states with their names, United States states, sorry. The state code and the population. And so we could do a join between states and populations, and that will get us the key, which would be the state code, and a tuple containing the element from the first RDD and then the element from the second RDD. See if I can.
You don't have to specify what the key is.
The first element is the key, that's it. You are specifying it, it's the first element. There it is. Yeah, there are no choices. It is the first element. Just like with reduce. You can have it any color as long as it's black. This will probably load in the right folder. Haha. In the simple folder, I have the joins. And this is the first element that it would return. So it has the key and then a tuple containing the value from the first RDD and the value for the second RDD. So it's a nested tuple. This makes sense. Let me actually deviate a little bit. And the other thing that I wanted to make sure you get out of here with is the idea of how do I create an app, right? Because the shell is really cool when you're playing, but eventually you want an app, right? You want a full program. And so I have in the sales folder a bunch of examples. And I want to quickly cover this, and then we'll go do data tables, because they are probably more useful. You need to import Spark context you probably want to import SparkConf. You don't actually need to. You can just create a Spark context and it will go local. But normally you want two things in your configuration. You want the app name and the master, which I don't have on this one. If you have something that is going to run for a while, Spark actually gives you a UI where you can see which apps are running and things like that. So if you have a big cluster where you're going to have a bunch of applications running, and so having a name for your application is a good idea. So you can see it in that UI and figure out who is taking that much time and that kind of stuff. And of course, if you have a cluster, then you'll have a master. If you don't care about that stuff, just this will work. And that just gets you a Spark context on local. And that's it. I call it SC just because that's what the shell calls it. And you can cut and paste your code from the shell onto this. Does that make sense? Let me go over this application. It is an example of dealing with sales. You have stores, and so I have all my standard, or same as the person. I have a store with ID and name. I have a product with ID, name, and category. Not even a price, sorry. It should be there, but I didn't. My examples don't have it. And then sales. Where I have the day, the store ID, the product ID, and the quantity. This application, let me see, can I make this thing wrap words? Oh. Okay. This will probably not parse as Python once I start putting extra lines, but I can just go load from stores, products, and sales. And by using these kinds of things, I could be loading that from a month, a year, whatever. Things like this would allow me to this is, again, I need day and the quantity. I'm going to calculate stores by day. And so day and quantity, and I can call reduce by key. One thing, you can save as text file, and that will save, sorta, kinda. We're gonna see how it works in a sec. We are calculating sales by store. We join with store names. And we can save, we do a map to print it the way we want it, and then save, right? I'm not going to save this, hoping that it didn't destroy it. Don't save. If you're going to submit a program, you still need PySpark to do a little bit of magic, or not PySpark, Spark. So you use Spark submit. That will be the in this case, we would need, I'm in the wrong place. Hopefully it actually runs. And we have this. Now, an interesting thing is how does Spark save files by default, right? You have this stuff in different nodes, right? So it wouldn't make sense to serialize your saving, right? You would need to, you cannot do it in parallel. So what it does is it saves a bunch of different files in a folder, just like Hadoop. So it saves part files. So what we have is part 0000, part 001, and then success. Success is just an empty file that tells you, yes, it worked. And if you don't get it, right? Because again, some of your nodes may work and some may not work. So success is done by the master when it knows that everybody, that everything worked. And so you have, in this case, 2 files. And you need to concatenate them together to see the actual output. Because it depends on the number of processors you have and partitions. I think it does 1 task per processor, or I think one task per processors minus 1, because it leaves you 1 to work, and this is a netbook. So if you had a quad core or something like that, it may do 6 or something. And again, right, there's actually only 2 tuples. So depends on the number of nodes in the cluster, yes. Basically, every node or every partition will have 1, yes. No, depends on how you read them, right? If you read them from Linux, there's 2 different files, right? If you read them from Hadoop or something like that, there is. If you have HDFS, then yeah. In fact, you can use the text file. I think will read this automatically. Just reiterating, to do the applications, you need to get a Spark context, which is this. And if you actually don't want to pass, you don't even have to pass the configuration. If not, you can use it to set the master or your application name or those kinds of things.
So SC is populated for us in this interpreter.
If you use PySpark, if you write your application, no. And so that's why I'm doing sc equals spark context, so I don't have to modify my files. I name it sc2, and so life is good. But you could call it anything you want. In fact, I think a couple of the things had it as Spark, right? One of the examples had it as Spark rather than SC. You can use save as text file to save. It does part files. And actually, Spark, by default, includes the 1,700 libraries for Hadoop. So you can save in a bajillion other things. You can save as Parquet files, save as a bunch of other things. If you don't know what those are, then that's cool. Save as text files works. Some other functions. We have sample, which will sample data from your RDD. And you can specify whether with replacement or without replacement, the fraction of elements you have, and the seed, so it is repeatable. It's a random number generator seed. We have union, intersection, distinct. We have coalesce and repartition that let you either create more partitions for an RDD or create less partitions for an RDD. So coalesce will reduce the number of partitions, and repartition, I think, can go either up or down. So if you want more nodes or more partitions are smaller than nodes. The same node may have more than one partition, but you can try to scale. Aggregate by key is slightly different than reduce by key. It just takes a slightly different interface, the other kind of reduce interface. If reduce by key is not what you wanted, you can use group by key, which usually is slower. And that will get you the key and a list of all the elements. And so you can actually do things ordered and things like that, as opposed to just. Actually, reduce by key will potentially, if the group is in different nodes, will apply the reduction on each node and then just send the reduced values. So group by key guarantees that you get all of them if you ever wanted to do that. Depending on your algorithm, that may be what you want. And then you can do other kinds of things, repartition and sort within partitions. That will repartition and make sure that everything is sorted. And so that allows Spark to optimize some of these things. And you can do actually map partitions. Rather than map to the whole thing, it will map for each part. It will run map for each partition. So that allows you to do other things. This would be mainly weird things for performance, other than sample. And then we can talk about data tables. Data tables are a lot nicer. It's like an RDD, but it has schema information. So in a way, you get objects without having to do parsing or anything like that. It is very similar to a table in SQL, almost. It is very, very similar. It's almost a port of this interface to Spark to the data table in Pandas. If you do data analysis in Python, Pandas is a very widely used library for that. You can think of it as they are basically Python objects with no methods or something like that, but they know all their fields. So you can get the fields. So each row knows which fields it has, the data table knows all its rows and knows all its columns. Of course, in here, all rows have to be of the same size, of the same type, right? Basically, they have the same fields. When you're doing stuff with Python, your RDD could contain objects of completely different kinds, and you could be doing different things on them, right? Here, you can't. Right? They all look the same, but doesn't have to look the same because you can have nulls, and you can actually have arrays as one of your data types. We specify queries on them. You can do it like an RDD, or there's a SQL interface, which is nice. We are going back to query optimizers, right? One of the cool and horrible things about Spark and Hadoop is that you are specifying exactly what gets done, right? You say, first do this map and then do this reduce, right? It cannot do it any other way. Here, it's going to be optimized, and so it's going to be done whichever way the machine thinks is better. Now, chances are that is better, but you are relinquishing control. We are going back to kind of relational databases, sorta, kinda, but big. However, the incredibly nice advantage is you pay an almost negligible Python tax. All of this stuff is done by the query optimizer in this other thing. So there's basically no, other than, actually, if you're displaying stuff on the shell, other than the final thing that sends the objects to be displayed by the shell, there is no Python, right? Sorta, kinda. All of the RDDs are RDDs. You're using Python to send the commands, but there's no translation from Python to Java. And if you save as text files, there is absolutely, right, none of those objects actually leave as Python objects. The RDDs do, but the rows are never Python objects, which means you don't pay the performance penalty. Now you need to specify the schema. The easiest way to get a data with a schema is by reading a JSON file. It is not a JSON file, but it's a file that looks a lot like JSON. Every line, it's a text file, every line is a JSON object. JSON is JavaScript object notation. It's supposed to look like things in JavaScript. It's not quite the same. It's basically put quotes around your field names, right? So field name, column value, and put quotes around your field names. And you can only use double quotes, and that's it. Yeah, I'm here. Did I put it here? No. Yeah, I did. We also have to use a SQL context rather than a Spark context. The SQL context is, of course, derived from the Spark context, but so we would use something like this to read the data. Let me show you what the data would look like. Everything is a sort of JSON object, but there is an extra limitation that every object is in a separate line by itself. here is the cool thing. Ah. We can do this. People equals SQL context dot JSON file and pass it the path. And then it doesn't work, of course. It sort of enforces that the type of every row is the same.
Right, so I ended up replacing like C# at one point for 1, and it didn't mark at me, which is sort of surprising. And I'm wondering, like, at what point would I decode?
Actually, what it enforces is that every row is the same way.
Oh, okay, so you have to have the same column.
You have to have the same columns,
Okay,
exactly.
but the data type itself.
Yes.
Okay.
And actually, it assumes that it is the same. I don't know if it enforces it. You can probably do a union of two different RDDs that have different things, and it may not enforce it until you try. There's people, yeah. People are people, not numbers. Sorry. Cool. And this is actually reading, and the first time takes forever because it does all sorts of magic. Actually, one of the bad things, it creates stuff in your folder. It actually starts an instance of a database just to keep track of schemas and things like that. So it creates stuff that shouldn't be there, but oh well. One really cool thing with you can still do the normal things. This is still an RDD, right? Actually, we can do people and see. It is a data frame, right? And it knows all the columns, right? We can do first, right? It's still an RDD. It will give me rows. Even nicer, I can do show, and it actually shows me something like you would expect from a database, right? Why? Because now it knows all the rows and columns and things like that, right? My network is acting up, which probably means that this won't work anymore. It does. Cool. By default, show will show the first 20 rows. which makes sense because if you have 5 trillion rows, you don't want to display all of them. Now it died. Okay, it's cool. I can still use it. That is good. We can actually do the normal data RDD things, right? We can still do reduce and those things. We also have select, which is basically map. You can use either the so we can do people.select and we can pass a string name. And that will select only the name. We can also, instead of passing the name, we can pass the column. People.name is a column, right? So if you do just people.name, tells you there is a column, right? And it actually knows. And so we can use it, and we can actually do magic. People.name plus 1. Oops. That's probably bad. People.name plus 1 doesn't work. People.age plus 1. This is slightly magical, but it is magic. So there are limitations of what you're doing, right? It's not a Lambda. It's something that sort of kind of gets compiled to a Lambda, right? But you may not be able to do everything you want. Does that make sense? Now there is one more layer of magic involved. So we can do select, we can do filter. I always forget to add show, so I can see. Since you're referencing the column, you have to do people.h or whatever is the name of your variable, right? Because what you're passing is a column, and that's how they do the magic. You can actually use the pandas syntax for filtering. So you can do people and use square brackets. If you use pandas, then it's nice that you can use the exact same syntax. If you don't, then you may prefer the other one. Now, group by is slightly weird here. You need to specify first the group by, and that just groups, but it doesn't know what it's going to calculate. So you specify the group by, and then you specify what you wanted. So we can do people dot that just gives me a grouping, and it doesn't know what I'm going to do with it, right? So I can do dot count, and that will give me how many people. Bless you. I can do other kinds of things like this. Sum of age. The interface is nice. Yes? That depends. Map scales constant with the data size. Keep in mind, these things, right? There is a huge overhead of, there's a large constant overhead of optimizing the query, right? So it takes a couple of seconds to optimize the query. It takes 1 millisecond to actually operate because I have 2 things in RAM, right? But it takes a constant time to optimize the query. That is constant. All the map operations are embarrassingly parallel, right? They basically scale linearly and they get divided by the number of nodes. If you have just add more processors, it maps scale beautifully, right? Because you're just applying the same operation, so you can do it in parallel. It's not perfect, because you're not guaranteed to have the exact same number of rows on every node, but it's basically completely divisible. Reduces and joins are not. It is not bad when joins are pain. Joins are terrible because you have to transfer data across the network. What Spark tends to do, and you can actually do the partitioning yourself and things like that, it does kind of a, if you partition your thing by keys so that all the keys, either by range, all the keys from 1 to 10 are here, the keys from 10 to 11 to 20 are here, or just by hashing, I just hash it and divide it among all my nodes. Then when I do a join, I don't need to compare, since I'm only doing equijoin. I'm not checking greater than, less than, I'm only comparing for equality. My join is still quadratic, is still this by this, but I only need to compare those in the same bucket. So it scales reasonably well. It is still an obscene amount of network traffic, because the partitions may not be in the same node. Yes? If you partition things explicitly, there are things that you can pass a partitioner explicitly, and then it will do it. It actually knows how it was partitioned. What there is no way to is, sometimes like I'm doing HDFS, and so I know that this file, the file that ends in 1 contains only things with 1, the file that ends in 2 contains only things with 2. That you cannot. Exactly, you can't tell it that. You can run a partitioning, which will be very fast because there is no network transmission, right? But you cannot, as far as I know, there is no way to tell it. Any other questions? No. One really cool and horrible thing is that you can do SQL. I love SQL, so for me it is really cool. If you thought you'd do big data and not do SQL anymore, then it's not really cool. We need to register our RDD, right? And tell this SQL processor, okay, I'm gonna be referencing this RDD with this name. So we can either do it this way, I'll show you the other syntax. We can either tell the RDD register yourself as a temp table with this name, or you can tell the context register this RDD as this name. And then after that, I can run SQL queries. I have a SQL method, and then I pass it a string with SQL. And it sort of kind of works. Isn't this cool? We are back to square one. The data tables feature is fairly new, right? It was just officially added 2 weeks ago. So you're getting the newest thing. When I read about that stuff, it's like, oh, I'm doomed because I need to prepare my slides until after that. Because I had to include this. This is really cool. They say that their SQL parser is not that good yet. So it's like, okay, if you can use Hive's SQL parser instead of this, but it has done everything I've thrown at it. So. You can do group bys. If you really have to, you can mix and match. So you could actually apply maps and reduce. And now, let me show you. The data table actually has a join method, we can show in a second. You have group by. We can specify several fields in the group by. We need to specify the aggregates. I'm going to show you how to do it with AGG. Lets you do a bunch of aggregates at the same time, as opposed to just one, like count or some. SQL. And so let's do a nice example. And there is the other way of doing it, right? Because having your data in JSON is not good, right? There are several other things. Actually, Spark will read data from almost anywhere. I didn't have a chance to hook it up to a normal relational database just for fun. You can use JDBC and have it read from a database. It can read from Hive and Parquet and all those things. And if those guys have schemas, then this will already be imported with the schema. Now, if you don't, right? If you're reading from text files or something like that, you can get an RDD. here we have the sales RDD, our standard plain RDD with tuples, right? So we split and we map to create tuples. And then we can specify a list of fields. Struct field, normally that's what you want. What you're going to have is a struct type. You can do arrays and things like that, but normally what you have is a tuple. You use struct field, you specify the name, the type, and whether it's nullable, whether nulls are allowed. And so I have string type and integer type. And since I'm not doing date calculations, I'm counting all my dates as strings. If you think of them as dates, then you can parse them. And you specify, right, that's your schema, and then you call SQL context dot create data frame, you pass it the RDD and the schema. Now that thing will be a SQL context, will have all the schema information, and you can use all the data table stuff, you can use all the SQL stuff. Let me cut and paste and see if this actually works. Not all. I need to modify the whole thing. I don't need these pieces. You need to import everything from PySpark SQL and PySpark SQL types. Or I'm just doing this so I don't have to repeat it all over. We can register our tables. And then we can do SQL including joins and group bys and everything. If you don't like the SQL interface, you can basically do this exact same thing with group by and join and all those things. One thing that I wanted to show is this. If you want to do more than one result out of a group by, right? You would call sales.groupby, and then you will use ag, and then you specify your columns. In this case, I'm specifying that what I want is the min from the column store, and I want to alias that as min store. And you can just keep specifying them. In order to use the functions, you need to import them from pyspark.sql.functions. And so I'm doing it like this. But if not, you can just do SQL. If you really, really want to, you don't want to unless you have to, but you can ask explain, and it will tell you how it is optimizing the query. And you can go read the documentation, but it's usually, you can figure out what it's doing, right? It's eventually gonna project a bunch of attributes. It needs to do a join, and it's gonna use a shuffled hash join. So it's basically gonna just hash strings into buckets and use those buckets to do the join, right? It has to do the sending stuff, the exchange. Eventually there's a physical RDD. There is another exchange, so it needs to send the data from the other thing, another physical RDD, which was the stores, does the join, and then projects only the columns that we need. And so it is usually possible to look at those things and try to figure out why things are not fast enough. Try to guess why things are not fast enough, right? But again, we are going back to now I have a query optimizer that does things for me. And so now I need to go ask that query optimizer what's it thinking about doing and how it's going to work. Does that make sense? We can talk a little bit about performance. And it's basically what we have been saying, right? Spark in Python is slower than Scala due to translation, but not with data table. So if you're using map and reduce and those things, it will be slower than Scala. In fact, somebody was asking me, should I just use Spark in Scala? If you're going to be doing Spark, right, then probably yes. If you're a Python programmer who's going to be using Spark sometimes, then of course use Python, right? If you're going to use Spark 8 hours a day, then probably it's going to make your life easier to do it in Scala. But, however, if you're using the data table, you don't really need to, right? Because most of those are just one simple tiny call to something else, right? And then all of the code actually runs in Scala. Data table should be able to optimize better, but you're trusting somebody else, right? You're trusting magic. We do that all the time, right? I mean, Python's interpreted. You normally don't compile it. You trust it to be fast enough. You trust it to work, but shuffling and so join and reduce are very expensive. If you play with partitioning, you can help. If you partition your things, then that can help. There is a great talk on performance and Spark. There was a Spark conference a couple of months ago, I think. There's a great talk on that. I was stealing a couple of the slides to talk about performance. An RDD has its lineage. It knows the set of partitions or splits, has a list of dependencies on the parent RDDs, has a function to compute the partition given its parents that gives it resilience, right? If a node goes down, the RDD knows how to compute back all the information again, right? It has a couple of things that help with fast execution. It has a partitioner which tells it which objects go on which partitions. And so if you have, and you can specify which partitioner to use. You could even create your own partitioners. Normally, they have by default range and hash. So you either just hash one of the fields, or you specify ranges for those fields. So it will try to guess what's your overall range, how to partition it in about equal sizes, and go from there. These things optimize for one key, right? If you optimize for one key, then it's wrong for every other key, right? But that's what you get with distribution. And so you can do that. Specifying the partitioner can help a lot when doing any kind of shuffling, when doing reduce, when doing join. Knowing that I have all the data in this partition, I don't need to exchange, right? Can make you reduce a lot faster. And knowing all the other rows with this key are in this partition can make your joins a lot faster, right? At the cost of potentially having to prepare your data. It also has a preferred location for each partition. None of the stuff we have been doing does. If you use something like HDFS, which comes from Hadoop, it's a distributed file system where each node has pieces of the file. And so this will know, and it's actually Hadoop aware, basically, okay, if you need this piece of the file, right? If you need this file, it is on this node, so put it there for Spark. So instead of going and reading and having a lot of network overhead, all the reading is done locally if it can, or a lot of the reading is done locally. Which may go against the partitioning if you want it partitioned by a given key and those kinds of things. But if you do Hadoop, one of the big advantages of Spark over Hadoop is that by default, the stuff stays in memory. In Hadoop, besides the fact that the interface is ugly, you have to write kind of much lower level code. Normally, it reads a file, writes a file, right? And so if you're going to iterate over the same data, Spark is nicer because it keeps it in RAM. And it will do the standard stuff, right? It will keep it in RAM if it can. If it needs the RAM for something else, it will kill the things because it can recalculate them. If you do cache, you can call the cache method, and that kind of tells it, please try to keep it calculated. And you can also save as files so that rather than recalculating, it can just read it from file, and that should be faster. And that can make iterative algorithms way faster than Hadoop. Any other questions, comments? Do we think we have about 15 minutes? We want to go over something. I went too fast over the other stuff, but I wanted to cover these data tables.
No, I just had a question. Back on the Panda style interface,
Yeah.
I tried to do a query that was, conjunction, this and that, and it didn't work right. Is there something weird about the sequential operations there? Female and age above 30.
Yes, and it didn't work. No, they probably don't have the and being special.
It didn't error, it just gave the wrong result.
Oh, wait, how does that work? Now that would be interesting. So, you still have people, right? Ah. So you did people of age greater than 30 and gender. Is that what you did? Ah, people.age, sorry. Yeah. That would be amazing. Oh.
So what's going to happen there is,
It's only, sorry.
so Python Boolean short circuiting means you'll just get the left-hand side of that expression, and like that will never work, not even in pandas.
Okay, so you need to do it this way.
The logic, I can't remember what logic one it is.
But this should work. Basically, the AND is not magical. The AND is the Python AND, so it's not going to work. They need to have some magical thing that does AND, right? NP? Okay, so the magical AND for pandas is %? Oh. Ah, this guy. Yes, yes. The AND is the Python AND, and so it doesn't. But this is the magic, and so I'm assuming that OR would be this. Cool. Any other?
Can you show again how you, it was effectively importing a Python
Context?
Yeah.
Or
That
the,
had a class.
the minus pi files? It's basically to any of these guys, either to pyspark or to spark submit. You have the option of just passing --pi files. And then you can pass
But you have to know that at the time you start the PySpark interpreter.
yes. If you're gonna do it with PySpark, yes. If you're doing Spark submit, then you're submitting an application, so you need to have everything there.
Normally in Python, if you want to import some file that's far away, you can modify the sys path and add a path to it, and you can then import. But you can't do that here.
No, because this is actually going to nodes, right? Officially, this isn't a bunch of computers, and what this thing does is it actually probably compresses them and ships them over the air, so that has to be done, as far as I know, at the beginning. You can probably find a low-level way to send it somewhere, but why? Just do Control-D and start again with more Py files, or a zip or an egg file or something like that.
So we've looked a lot at using Spark and front end of this. To do that efficiently, you need to have a cluster, right?
Yes.
Can you show us or point to some good resources for how to set up a cluster, say, given 100 or 1,000 machines? What are the approaches people use for that, or where are the dots on how to do that?
Maybe. I can point you to some resources, but I think Google will do a better, or Bing will do a better job at that, especially Bing. But it's what I have done, right, is set up small clusters, right, of a bunch of Hadoop machines on a bunch of Linux boxes on Azure, set up a Hadoop cluster, that kind of stuff. The Hadoop site has that. I tend to go the ugly way, which is I actually go download the things and set them up. Because normally when I want to do it, what I want to do is learn. If you just want to have just want to have a cluster, like what we do at Microsoft, somebody sets up the cluster. I don't know how to set up a big cluster because thank goodness I'm not doing it. I'm just using it and it's beautiful. Has several thousand machines and I don't worry about it.
The reason I'm asking is because I'm the person who gets to do it.
If you can, okay, if you're the person who gets to do that, then yeah, you have to do it. I can point you to some Hadoop resources. Both Azure and Amazon, AWS, and probably a bunch of other guys have it where they set it up for you. Of course, I haven't used the AWS thing in at least a couple of years. But Azure HD Insight is beautiful. It will automatically set up a cluster for you with, I haven't tested Spark. It sets Hadoop, Hive, hooks it up to blob storage and things like that. I am sure Amazon does the same thing. They call it Redshift. Basically, they set up a cluster for you. And so if you are a normal person and you're asking me how to set up a cluster, my obvious answer would be contact a Microsoft guy and get an HD Insight thing. It's actually not that expensive. But if you're the guy who has to set it up, then... And a lot of it is also not just setting up Hadoop and things like that. It's not that bad, and the documentation tends to be done by people who set up Hadoop clusters. So usually the documentation, it feels good. They're telling you the right things. They're telling you what you want to know. There is 3 or 4 the problem is there's 3 or 4 services that you have to run.
Sorry, Spark's not Hadoop or am I?
Spark is not Hadoop, but Hadoop is not Hadoop anymore. 3 or 4 years ago, right, Hadoop was the thing. And people started building stuff on top of Hadoop. Now when people say Hadoop, they mean Hive and Pig and 17 other things. So when people say Hadoop, they don't mean Hadoop anymore. Hadoop has the 2 low-level things are HDFS, which almost everybody uses. That's the distributed file system. You have 1 million machines with 1 million hard drives, and your file is spread out over all those 1 million machines. So even though it looks like a terabyte file to you, it's 100 meg files on 100 different machines. So it's actually very fast to load, right? sc.txt files is actually very fast because it's spread out over 100 machines. So HDFS is one of the things. The other thing is the scheduler. Hadoop used to have a scheduler. I don't know what it was called. Now it uses Yarn, which is the new scheduler, which is similar to Spark. It uses a directed acyclic graph instead of just map and reduce. I don't know how true it is, but I always think of it as kind of coming from Microsoft Dryad technology, because I work for Microsoft. I had to put the plug in there. No. So you get the scheduler and you get HDFS. And then you build on top of that. Spark can either run locally. We have been running it locally. There is no Hadoop whatsoever. It can run on top of Yarn. So basically when you do sc.map and sc.reduce, when you execute, instead of doing it locally, it will go ask Yarn, please schedule these 1 million tasks, go do it. And so if you have HDFS and Yarn, it is a lot faster in that sense, because all the things go through Hadoop. But Spark is not. It is Hadoop, but it's not Hadoop. When people say Hadoop, they mean all those things now.
So if you're running it locally on, say, a 12 or 32 core box, just as we've been doing today, how do you configure what process servers get used for running Spark stuff and how things get configured, or it just happens?
It just happens. It sets up I think 2 processes per processor, I think. You can also, and it's fairly easy to set up There is, in the bin folder, there is start, oh. Ah, there is sbin. If you go look at the sbin folder of Spark, there is start master that will start the master. Then you can start either one slave or a bunch of them. So you could actually put them in different machines as long as you set up maybe SSH. And now you get into clusters again, right? Now your files, when you say read a file from here, the file has to be available. You're only passing the path, so the same file has to be available on all machines mounted on the same paths and things like that. And it just works. You don't really need a Hadoop cluster or something like that. It just works. Which is a heck of a lot nicer than setting up a Hadoop cluster.
So the file has to be mounted on a shared file system.
It doesn't necessarily have to be, you're passing a path. The path has to be valid all over. Usually by a shared file system, but you could actually sync all the files, right? As long as they all have a /data/people.txt, right? It's going to be read. It doesn't matter. Yes. Actually, that is more if you have a bunch of files, right? You could actually have different files on different machines, and you load it with a star, and it will go do it. I think. But yes, you can get yourself confused fairly easily. So you probably want to mount it as a shared file system. But if he's setting up clusters and things like that, then that's normal. He probably knows NFS and that stuff, right? Or no? You don't use NFS? What do you use? GPFS? Cool. I'm learning. I learned Vagrant. So now I'm learning more stuff. Yes? It attempts to recover. I think by default, you can actually set up as one of the parameters kind of how much replication you want. I think by default, it sets it in 2 or 3 nodes or something like that. And also, it keeps the lineage. So if a node dies, it doesn't matter. It will just set up the computation on a different node. It may need to backtrack, but it works up to a point. If you have a long-running computation on 100 nodes and a node keeps failing every hour, then you're doomed, right? But if one node fails, it should work. Should. No warranty. In Spark. In Spark, yeah. Data tables, actually Pandas has data tables that's, I don't know the history, probably they copied it from R, but that it's just new in Spark. It's really new. It came out March release, and it wasn't March 1st. It's something like March 15th or something like that when they released 1.3. But now it's there. I am assuming the query optimizer and things like that will probably get a little bit better. I'm assuming there is still a little bit that can be improved over there. But I haven't actually looked at the code. No other questions? And it's 8:59 a.m. Woohoo! Okay, 9 a.m. Eastern time. It's noon. Are we supposed to be done at noon? Maybe. No? 12:20? We have 20 more minutes? Cool. Do we want to go over something else, or do we want to? Sorry, I assumed it was 3 hours. I was timing myself. Shouldn't have gone that fast over the objects. Is there anything else? Now, shall we get out of class early? Cool. Any other things? And you have my emails all over, probably. Any? No, thank you.